This is the volume of fluid displaced volume of fluid displaced. The weight of the body equal to 143471. So volume of fluid displaced equal to 143471. And weight density, this is the fluid means water, 1000 into 9.8. G value is, so the value is 14.625 meter cube. Now this is the volume of displace, and now volume of displace value is the position of. Now the question is, first one is already calculated. Now position of the center of buoyancy. Position of center of buoyancy. Center of buoyancy. First, volume of displaced fluid equal to this with this length into width into depth h. This only this portion is not displaced, only this portion is displaced, so equal to 14.625. so h equal to 0.975 meters. Center of gravity is 1.5 divided by 2, 0.75, but center of buoyancy, the center of buoyancy equal to h divided by 2, h by 2 equal to 0.975 divided by 2, the value is 0.4875 meter. Understands? Now how to solve this? The block, steel block, floating water and mercury density is this. The upper portion is filled with water and down portion is filled with the mercury, and their depth, steel depth in water A, and mercury, the steel block depth in mercury B. And so the cross section of block is as A, and the specific gravity, the density of block 7.85 into 1000, so 7850 kg per meter cube. Now the weight of the block, weight you can say weight of displace, weight of what, this is fluid, this fluid, mercury and water interface fluid displace is equal to weight density into volume of displace. Volume is A and the volume and the depth is A plus B. Understand? Now the buoyancy force equal to the weight density, weight of the fluid. Suppose this is the W, and buoyancy force is upward portion, and this is the This one is total buoyancy force of this portion. So AB equal to this portion, weight is rho into water into G, A into A, this portion plus rho mercury into G into A into B equal to rho G A into A plus B. So A cancel out, G cancel out. This is density of the, and this is the density of the block. Water density is rho 1000 into A, mercury 3600 into B plus 7850 A plus B. So the now calculates it, and A plus B, A by divided B 0.839. This is very easy to calculate. Next is metacenter. What is metacenter? A point, it is the point at which, about which, a point about which body start oscillating. A body, a floating body, point about which a floating body starts oscillating when the body is given to small angular displacement. Small angular displacement. And another definition is, it is the point and definition, it is at which line of action of force of buoyancy meet with normal axis of the body. When the body is given when the body is given to a small angular displacement. displacement. Suppose this is the floating body. This is the floating body. This is the floating body. Suppose this is the center of gravity, and this is the center of buoyancy. This is the center of buoyancy. Center of gravity, the middle portion of the body, and this displaced fluid middle portion is B, this center of buoyancy. This is A, and this is angular displacement. Angular displacement. Here at this point weight is acting, and this point is FB is acting, FB, and at center of when a body is given to a floating body is given to a small angular displacement, the center of buoyancy shifts from B to B1 in new position, and the point at which line of force of buoyancy meet with normal axis at a point M. This is the call, M is the call metacenter. Understand? Metacenter. And here at this position AB is acting, and this position weight is acting. This is at this position AB and W given small angular displacement clockwise sense, and AB and W is generate a couple acting in the counterclockwise direction or anti-clockwise sense. Then the body return or beginning the body its original position. Understands? And next is metacentric height. Metacentric height. What distance between, this is the distance between metacentric, or distance between metacentric of the body it is the of a of the of a floating body and center of gravity of the body. Center of gravity of the body. Center of gravity. Next, metacentric height. GM. GM means the distance between the center of gravity and the metacentric of the body is I divided by volume of fluid displaced minus Bg. I is the moment of inertia of plane of body about y-axis, and this one is volume of fluid displaced. Understand? Now this is stability of a floating body. Stability of floating body. Number 1, stable equilibrium. This one is stable equilibrium. For stable equilibrium, M, the point M is above G. Then the body is said to be the floating body. Here the floating body is in stable equilibrium. Stable equilibrium. And another point is GM, metacentric height, should be positive. Or GM greater than 0 means. Now stable equilibrium, suppose the body is floating. This is the floating body. This is the floating body. Suppose this is the floating body. this is G, this is B. This is the normal axis. This one is G, this is the B. This is the angular displacement, angular displacement, and this is the M, metacentric. This is the B1. This is the B1. This is the B1. This angle is theta. First, when a floating body is given to angular displacement in the clockwise direction, the center of buoyancy shift from B to B1. From B to B1, that time this is the weight and this is the FB, and W and FB in the anti-clockwise direction generate a couple acting on the anti-clockwise direction and bringing the body in its original position, and then the floating body is called stable equilibrium. This point is very important. M is above the G for stable equilibrium. Now unstable equilibrium, M is below G. Then the floating body is unstable equilibrium, and the is should be negative, less than 0, and that time